Okay, so let's go with the last topic for um, fuel and energy efficiency innovations. Okay, so we'll be go to the last topic, performance optimization software. Okay, so these are some of the softwares used for performance optimization for our engines. Okay, performance optimization software supports efficient operation by providing real-time monitoring and control of propulsion plant systems. So the goal is to reduce fuel consumption, improve engine efficiency. So there are the different ways to or softwares used for this one. So let's look at this one. Why optimization is needed? Okay, so marine engines operate under varying loads and sea conditions. So manual performance tracking can be inaccurate. It helps reduce waste and fuel costs and supports compliance with efficiency regulations. So the key parameters monitored using the software, we have the SFOC, specific fuel oil consumption, the engine power versus propeller load, cylinder pressure and timing, hull and propeller fouling, weather and routing efficiency. So functions of optimization software, real-time engine tuning and control, so health condition monitoring, and then fault diagnosis and or health prognosis, and then maintenance decision making, real-time engine tuning and control, predictive maintenance and diagnostics, power and energy management system, speed and route optimization. So there are some these are the more um, mostly used systems on board ships from Kongsberg, Wärtsilä, MAN, BMW, ABB, and Storm Geo. So these are very um, uh, familiar or familiar companies that usually works for merchant ships. Okay. Performance optimization software for Kongsberg KIMS. So these are the example of their software. So you can see here the main engine RPM, the fuel index, the power curve, the flow, generator engine fuel flow, boiler fuel flow, hull efficiency, main engine fuel efficiency, generator engine fuel efficiency. So based on the datas in here, you can check your efficiency if it's still good or not. So there are different ways, there are different parts of this software, of course. We have the events, system status, generic views, trend, bridge data, vessel performance, steering gear, mooring, propulsion, power. So there are so many um, options in here. So this is the K-Chief from Kongsberg, KIMS. So Kongsberg KIMS, Kongsberg Information Management System, a data or operations collaboration platform. Onboard plus cloud. So there is a storage online that centralizes ship and process data and lets owners add tailored apps and dashboards. So information management or collaboration, collect and distribute ship or plant data, host apps and dashboards. So you can see here, and then if there is a problem, then um, that's the time you can do something. Next, we have another performance optimization software. We have the Wärtsilä Anyram. So Anyram, I think, is not an abbreviation of something. It's a name of a company, maybe. It's a collaboration, maybe, of Wärtsilä and Anyram. So from data collection to predictive analysis. So we have the real-time onboard Anyram vessel platform installed on core fleets. And then reactive analytics, initial reactive analytics in place with operational PDF reports and web tools. So you will receive emails, PDF reports, and web tools online. The NRM vessel platform enabled with predictive capability. So you can do maintenance before a major catastrophe may occur or may happen. Real-time data and performance dashboards, first generation of mobile operations and predictive analytics. And They have also this watch, wow, and cell phone connectivity, expand to new features and areas such as safety, security, emissions maintenance, and hotel operations. So this can be used on cruise ships also. So optimization software from Wärtsilä Anyram. A high frequency vessel performance and voyage optimization suite that uses digital twin hydrodynamic models and predictive simulations strong in cruise, ferries, premium ships. So we have discussed this already, digital twin, predictive simulations, predictive maintenance, performance and voyage optimization with digital twin simulation for hydrodynamic and energy system. So a very nice software for onboard use. Okay, another one, we have the performance optimization software from Man Sion. So Man is a very common manufacturer. So Man Sion, so they are now using their cell phones. Okay, so real-time updates using your cell phone. And then you can call your the manufacturer or the engineers from Man BMW online. You can talk to them also. So Man Energy Solutions cloud-based engine or asset-centric platform focus on real-time monitoring, analytics, and predictive maintenance for Man equipment. Now branded partnered with Everland Sion in some places. So uh, this- because nowadays Man BMW was branded to Man Prime Serve, right? And then now they are rebranded again, and their name is Everlands. This one, Everlands. So that is also Man. Okay. Asset or engine monitoring plus predictive analytics for manned equipment, real time, and for maintenance, predictive maintenance also. Another performance optimization software from ABB. So the name of their software is ABB Octopus. So this is not an abbreviation. Okay, so this is their Octopus. So the one thing that I like about their software is it's like a Sankey diagram. Okay, what is Sankey diagram? So we will discuss. So we have here a fuel. So this is the fuel from our fuel consumption. So we have 2,994 kilograms per hour. And then for the diesel engines, it uses 6,826 kilowatts for the losses, 10,814 for the electrical consumers, 35 to 7 kilowatts for high temperature heating, and for exhaust gas boiler. So you can see how the fuel is converted. So what are the losses you have? What are the things that is used to generate electric consumer, like the propulsion? We have the accommodation, chillers, ER auxiliaries, scrubbers, reverse osmosis, evaporators. You can see everything, and it's plain and simple. You can see it directly on this diagram. Okay, so this is like a Sankey diagram. So what is a Sankey diagram? So let's have an example. This is a Sankey diagram. A useful energy on the powertrain is shown as a vertical flow. So this is a vertical, but on the ABB Octopus it is in a horizontal style. Okay, so this is a vertical flow to the top, while losses branch out to the right. The display can be toggled between megawatts and percent. So the width of the arrow is proportional to the flow rate. Okay, so you can see we have here the fuel of the main engine. Let's say it's a main engine, 100% of the fuel. So 49.3% of the fuel is used for shaft power or for propulsion. The other 2.9% is lost but in the lubricating oil cooler. And then 5.2% is lost in the jacket water. And then 25.5% is lost in the exhaust gas. So maybe in the exhaust gas, we can reuse this lost thing. So we can put turbocharger, we can put economizer, we can put steam turbines to reuse the exhaust gas, right? Air cooler, these are the losses, and heat radiation, 0.6%. This is a Sankey diagram. The width of arrow, okay. Another example of a Sankey diagram with a waste heat recovery system. So 22.9% was put into exhaust gas and economizer. From 25.5, it it became to 22.9 because the other 5.1% was gained through use by using turbocharger, by using economizer, or from any waste heat recovery system. So that's another example of a Sankey diagram. So here is this Sankey diagram. So power here is 48.91%, 4% for condenser, exhaust gas. So these are the losses. But you can also reuse this. Jacket cooling was reused for heating the freshwater generator. So you have um, a discount or what, a savings. Another Sankey diagram from the fuel 100% is the main engine. So part was used for ship. So there is a ship resistance, C margin, hull losses. So you can see the losses in this way. So this is for ship propulsion. So this used to counter the ship resistance. Also, we have a small fuel consumption on auxiliary engines and on boilers, and you can see how the losses were made, where the losses are, and how the power or the fuel was used. Okay, so this is an example of another fuel Sankey diagram. Grabe, wow. So from the fuel 100%, almost half, maybe around 60% is used for the main engines, going to the gearbox and to the propulsion. With losses to the environment, we have here from this one, we have lube oil cooler, and then loss to the environment also. So losses, these are losses. And then boilers, steam. Yeah. Ooh, this is another example of a this auxiliary engine. Blue is for electrical to the switchboard to the consumers, and then orange for the this HRSG shaft generator heating recovery heating recovery for the HT. Wow. So mechanical energy green, chemical energy heat loss orange. So the orange one are the heat losses. Yun. Electric energy blue and recovery energy is yellow. So these are the recovered energy in the yellow color. Wow. That's another Sankey diagram. Oh, another Sankey diagram from fuel energy. 41.8% is used for mechanical energy and 54.3 is waste heat. And this waste heat is used 25.5 exhaust gases lost, and then steam is generated here. Some 5.8% is dump steam, and then the other usage here is heating for the galley, engine preheating, laundry, pools, tanks, is AC, aircon preheating, evaporator. So this is a good also Sankey diagram. Cruise ship or hull or Holland America lines. So this is Sankey diagram they used in Holland America lines. Wow. Mechanical energy, electrical energy 40.5, propulsion is 21. Using the azipod 21.7. So there is only zero point 0.2 loss. Oh, not loss, thrusters. Only 1.3% generator losses. Wow. Hotel lightings, cabins, engine rooms, scrubbers, machinery, other galley, and HVAC. So another sample of Sankey diagram. So Sankey diagram is used in the ABB. So ABB Octopus, a modular marine advisory system on board plus shore, delivering decision support, motion, safety, energy efficiency with strong integration to ABB automation and electrical systems. So you will have also advisory and decision support. So there are emails or there will be calls on you on how to improve your ship. Advisory and decision support, motion, route, energy tightly coupled with ABB control systems and electricals. Wow. So fuel energy, you can see it in here, everything. In just a simple one show diagram, Sankey diagram. Okay, another performance optimization software, but this is not really on the engine side. This will be more on the bridge side, the Storm Geo, or it is a weather routing and voyage optimization software. So this is their voyage routing and voyage optimization software. So they will guide you where to go, what is the most optimum route, most fuel efficient route, so that you can go to your um, next port without any delays. Okay, so this is also a good optimization software. Weather driven routing and voyage planning with human route analysis, analysts, API integrations, and fleet level performance analytics. So weather plus commercial technical KPIs. Weather routing plus voyage planning combined with commercial or technical analytics and human analyst support. So you also have this support from online support that will help you in determining which is the best voyage for you. Okay, so let's go with the benefits. Benefits of this optimization softwares. So we have the improved fuel efficiency and cost savings, reduced wear and longer engine life, enhanced safety and fault detection, better decision making with real-time data. Additional siguro, we have online support. We have online support from analysts, from um, experienced engineers. Okay, and then you can also use this for slow steaming. So you will not be afraid of delays because you will be on time at the right time. Software suggests reducing speed slightly based on weather, saves fuel while maintaining estimated time of arrival or ETA. In summary, performance optimization software enables continuous engine efficiency, monitor engine, analyze the data, optimize your engine performance, and with the results of improved energy efficiency with lower fuel usage. Okay, so that's the end of our topic 10, which is for the fuel and energy efficiency innovations. So I hope you learned something today, and I'll see you on our next video. Goodbye.